All right, let me ask you something. When you hear the phrase, the observer effect, what comes to mind? A lot of people, maybe including you, imagine some kind of mystical, mind-bending scenario where human consciousness somehow magically shapes reality just by witnessing it. Like the universe is this enormous stage, and we're all main actors whose gazes force the show to run. Sounds dramatic, doesn't it? But let me share a truth bomb with you. That understanding of the observer effect? It's 100% wrong. No woo-woo, no mysticism, just pure physics. So, buckle up, because we're going to demystify this buzzword today and dive deep into what the observer effect really is, why it matters, and why, honestly, it doesn't need you at all. And don't worry, I promise to keep this fascinating, even a bit fun. Let's go. All right, basic background first. The observer effect crops up most famously in quantum mechanics. You know, that branch of physics that's so bizarre even Einstein scratched his head at it. It's all about the smallest pieces of reality: electrons, photons, particles so tiny they don't behave like anything you're used to. And one of the strangest findings in quantum experiments is that observing these particles, just measuring them, seems to change how they act. That has led to some truly wild theories, like maybe consciousness, the very act of looking, bends the rules of physics. But before you start to imagine the universe whispering back to you as you glance at your left shoe, let's pump the brakes. To get what the observer effect actually means, you need a little crash course on measurement in quantum physics. Think of a photon, a particle of light, playing a kind of hide-and-seek game. Before you measure it, it exists in a superposition, a fuzzy blur of possibilities where it's doing multiple things in multiple places at once. For example, when you shine light through two slits in a wall and look at the patterns it creates on a screen, the photon acts as if it went through both slits simultaneously. It's like it's hedging its bets, not committing to any one storyline. Wild, right? But here's the kicker. The second you decide to catch it in the act, "Hey photon, which slit did you choose?" and use a detector to track it, the photon snaps into place and acts like it went through only one slit. Boom. Superposition gone, single path chosen. Now many people jump here and say, "See, us observing it made the photon decide." But did it really? Let's dig deeper. What happens when you observe a photon in that situation is tied to the concept of wave function collapse. Think of the wave function as the ultimate cheat sheet on everything the photon could possibly do. It's a mathematical description, not some physical reality. It describes probabilities, like telling you that there's a 50% chance the photon went through slit A and 50% it went through slit B. Now, what happens when you measure the photon? Why does the wave function collapse? The thing you need to understand is that measurement in quantum physics is not just looking with your eyes or thinking about it with your brain. Measurement interacts with the particle, usually by hitting it with another particle, like a photon or an electron, and this interaction forces the photon to commit to one of its options. That's the real game changer here, the interaction, not your consciousness. In other words, measurement is physical. It doesn't have to involve you at all. If you set up a detector, like say a super sensitive camera, and leave the room, the act of measurement would still happen. The camera, as a system, interacts with the photon and forces that wave function to collapse. You're not special, I'm afraid. Human observers are not magic. The quantum world doesn't roll out the VIP treatment for your gaze. What we call the observer effect is really just a misnomer. A better term might be the measurement effect. Now, let me step back for a second, because I hear some of you thinking, or shouting at your screens, "Oli, this interaction stuff sounds suspiciously vague. You're not dodging the weirdness, are you?" And you're absolutely right. It is weird. Even the best physics minds in the world are still arguing about what wave function collapse actually means. There are interpretations like the Copenhagen interpretation, which basically tells us, don't ask, just calculate. Then there's the many worlds interpretation, which suggests the photon doesn't pick a path, but actually takes all paths, in separate universes. That opens an entire suitcase of philosophical and scientific debates, and yet, none of these interpretations credit you as the conscious orchestrator of the collapse. Why? Because the math and the experiments don't need you. They just need the measurement. You see, what excites me most about quantum theory isn't the idea that reality needs a co-signing human presence to function. No way. It's the realization that reality, even at its smallest scales, follows laws that are both beautifully systematic and infinitely perplexing. That photons, electrons, quarks, that all of these particles adhere to rules we're only just beginning to decode. Truth is, we don't need to inject mystical significance into quantum phenomena for them to be profoundly amazing. The observer effect already shakes up our perception of reality because it shows us that what is depends on how we engage with it physically. No magic wands or mysterious energies required. Now, here's another twist to blow your mind. The observer effect doesn't just show up in quantum experiments. You'll find versions of it in classical systems too, like trying to measure the pressure in a tire. If you shove a gauge into the tire, you introduce a tiny bit of air loss to get your reading. That's the classical observer effect. Not as exciting as wave functions collapsing, but still a nifty example of how observing, or measuring, a system changes it. And doesn't that just underscore the beauty of it all? Physics applies to every scale of reality, from the tiniest quantum ripples to the pressure in the tires on your bike. So, in conclusion, let's clear up this common misunderstanding once and for all. The observer effect doesn't mean the universe waits on you to look before it decides what to be. That's not how reality works. Instead, quantum mechanics reveals a world where measurement, not consciousness, plays the starring role. Where particles do wild, incomprehensible things until forced into a choice by physical interaction. And understanding this doesn't just make the world a little clearer, it makes it infinitely more fascinating for what it is, not for what we might want to believe. Now, if you found this enlightening, do me a favor. Like this video, subscribe to the channel, and leave a comment about what aspect of quantum physics boggles your mind the most. Hyperfocus is still new, but I created it as a place where we can dive deep into the wonders of science, free from the misunderstandings and half-truths that plague the internet. And remember to share this with anyone who gets a little too mystical when talking about quantum physics. Let's set the record straight together. Until next time, stay hyper-focused, and wave functions don't wait for witnesses.